Hello everyone. In this video, we are going to talk about building resilient microservices, and more particularly, we'll be talking about the circuit breaker and how it can help us to build the resilient microservices. So what's the agenda? Well, first, we'll talk about the real world scenario that can cause downtime, introduction to circuit breaker and how it will solve the problem, and lastly, we'll talk about one fun fact. Let's set the stage first. Let's say we have the payment service with some HTTP connection pool and it has some worker threads with timeouts configured. And we have downstream services with the payment service is communicating to. So we have the wallet service, we have the bank service, and we have the PayPal service. So when we have the client who wants to make a payment to the bank, the payment service basically calls the bank service. If they want to make a payment to the wallet, payment service makes they call it the wallet service. So let's say the wallet service catches a fire and it basically waits for a while before failing, right? So in this case, workers are taking long to respond. So as the requests are coming in, workers are waiting for the wallet service to respond before failing. And as they're waiting, more and more requests go in to the payment service and they are just queued. And in this case, the CPU resource is basically getting affected. Again, the clients are sending in requests. The wallet basically it's waiting for a while and failing, and as it's waiting, more and more requests are just coming in and they're getting hung waiting for resources to free up. In this case, all the other services are also getting affected. The PayPal service is getting affected. No more requests can go into the PayPal. The bank service is getting affected. No more requests can go to the bank because all the resources are being used waiting for the wallet service to just respond. You rather have a service fail immediately than wait for a while before failing, right? Waiting will just keep the workers busy. The HTTP connection pool workers will be busy waiting for the response. And as they're waiting, all the requests are waiting as well. And this has caused the entire payment service to fail, which is not what we want with the microservice architecture. With microservice architecture, if one service is failing, you don't want it to affect the other services. You want the other services to continue to function as you fix the one service. Now, what's the solution to it? The solution is to introduce a circuit breaker. The circuit breaker, what it will do is that when the wallet catches a fire, it stops responding, or it's failing and it's responding slowly. The circuit breaker will basically just stop sending requests to the wallet. It will just fail fast. So this way, we'll be having resources in our HTTP connection pool. The wallet service will just fail, but we will continue to serve the bank and the PayPal service, right? Fun fact, the term circuit breaker is borrowed from electrical engineering, where it is a safety device designed to protect an electrical circuit from damage caused by overload or short circuit. So when you have these appliances in your home, microwave, toast maker, or you have that board, that circuit board, these have something known as the circuit breaker. Now when power comes, like there's an overload or short circuit, the circuit breaker will just burst, right? The appliance will stay safe, but the circuit breaker is the one that will get affected. It will burn out, saving the device from getting affected. The same way in our payment service, when we introduce the circuit breaker, only the wallet request will fail and it will fail fast, right? But the resources will be freed up very fast and will continue to serve other requests. Right? All right, this is it. This is the end of the video. I hope you enjoyed the video, got some information from it. Please like, share, and subscribe for more. I'm hoping that I'll to introduce more of these concepts on building resilient microservices in the future. And I'm also hoping to share more on computer science and software engineering as a whole. Thank you, everyone.